So good morning, everyone, and thank you for joining me the next 30 minutes on the European Central Bank's cloud journey. My name is Christiaan, and I was born and raised in the Netherlands, and I'm currently living with my family in Frankfurt, Germany. And that's where I work at the European Central Bank as a principal financial management expert. As you are all aware, the worldwide shift to the cloud has accelerated over the past years, and also the European Central Bank is migrating the majority of its applications to the cloud. And in this presentation, I would like to share our experience with cloud migration from a financial perspective. So the challenges that we encountered, the lessons learned, and the things that we would have done differently. But let me first start by providing you an overview of the topics that I will be addressing throughout the presentation. So first, I will describe a little bit about the main tasks of the European Central Bank. And as I mentioned before, there is a worldwide shift towards cloud that has accelerated over the last years. And this comes with substantial advantages as well. You will probably hear things like scalability, flexibility, or using advanced platform services like machine learning or artificial intelligence. But managing the cloud spending can also be quite a challenge for some of the organizations, as cloud costs behave very differently than the traditional on-premises data center costs. And because of this different behavior between cloud costs and data center costs, there's also the risk that cloud costs can spiral out of control. This also means that when moving workloads to the cloud, but neglect to focus on efficient use of cloud services, this can easily result in higher operating cost than an on-premises equivalent. And in the last part, we will explore how the European Central Bank implemented or is implementing different measures to manage and optimize cloud spending. So let me first start by describing the main tasks of the European Central Bank. So the European Central Bank is based in Frankfurt, Germany. And the ECB, together with the central banks of the countries that have the euro, look after the euro, and all together they form the so-called euro system. The euro banknotes and coins are the legal tender in 20 out of the 27 member states of the European Union, and therefore the currency is used by more than 300 million people in Europe. One of the main tasks is price stability, meaning keeping the inflation rates at 2% over the medium term in the euro area. And another main task is the supervision of all the banks within the eurozone. In order to, there are many IT services in place that enable the ECB to perform its tasks. And also, as a public institution, we need to have the full visibility on the cost of each service. So in the European Central Bank, we have an ECB cost accounting system, and that is used to calculate the full cost of each IT service. So when we have an application, there are some common infrastructure resources that we have to allocate towards a specific IT service based on its consumption. So usually we have servers and storage and backup, power supply and cooling, network connectivity, and personnel. And every infrastructure resource can be allocated to the application based on its consumption. So like number of virtual machines, gigabytes of storage, kilowatt hours of electricity, network traffic, and so on. And this is also required in order to make a comparison when we're moving the application to the cloud. And once we have calculated the full cost of an application, we can also allocate the cost to the end user. And there are basically two methods in place. There are IT services that are being used by the entire Eurosystem and are being charged to the national central banks, for example, by sending an invoice. And there's the showback. So these are the IT services that are being used within the ECB, and full transparency is provided to the end user on the cost of each service based on what they consume. So this means basically that the budget and costs remain within IT, but this transparency is shown to the end user. As there are more than 100 IT services within the ECB, the cost accounting system becomes easily very complex, especially because the data that is required to calculate the full cost of an IT service is scattered among different data sources. So therefore, a lot of effort and energy has been invested in creating interfaces between source systems and our financial system. So one of the source systems is the CMDB, and CMDB has an interface to our financial system, so that all the so basically the allocation is performed in an automated way. And once the costs have been calculated, the full cost per IT service, the costs are then further allocated in an automated way to the end users. You will notice that cloud costs behave very differently than the on-premises data center cost. And understanding how cloud costs behave differently and understanding the advantages and disadvantages will also help you to better understand on how to manage these costs. So let's start by having a look at the behavior of on-premises data center costs. So usually the investments in physical servers or other hardware, on-premises software licenses, and other resources are required before we can use them. And then when there is a certain capacity constraint, we purchase additional hardware. So this means that this is rather CapEx, capital expenditures intensive, because we have to do an upfront payment and where we purchase the hardware. Then secondly, usually there's a standard process in place, a procurement process. So the procurement teams purchase the resources and manage the vendors, while the finance teams check whether the purchase was planned and whether sufficient funds are available. And the IT teams install and provision then the new infrastructure. This is also rather predictable because we acquire new assets with long-term lifespans, and they can be capitalized or depreciated over time. This also makes the evolution of the costs relatively predictable. And last point on the optimization, because the investments were already approved and purchased, teams don't feel really incentivized to better understand on how to further optimize all these already procured resources. Mainly until there is a point in time when we reach capacity constraints. And then people start looking into the optimization. Let's look at how the cloud costs differ from the on-premises IT costs. So there's a shift from upfront expenditures to variable expenditures. So variable expenditures mean that you only pay for the computing resources that you consume, instead of investing upfront in data centers and servers before you know how you're going to use them. You can see clearly on the graph that instead of paying for unused resources or having to deal with a limited capacity, you can access only the capacity that you need. You can also scale out in response to demand. So as I mentioned, these are variable expenditures, and it's more of a self-service concept. So the cloud has made it possible for a lot of users to acquire resources independently and almost instantly. The self-service nature of cloud services result also in a situation that engineers can basically spend money with code. And this could potentially result in a situation where procurement and finance are cut out of the loop. Compared to the on-premises cost, the costs are also more dynamic, and that's because costs are highly sensitive to usage patterns, and because cloud usage is measured and built in a pay-as-you-go model. The usage patterns may also vary unexpectedly due to changes in business activity, for example, or human errors such as inefficient configuration or scripting mistakes. And therefore, the spend is considered more dynamic and less predictable. But at the other hand, because cloud costs are variable, optimizing your cloud environment can result in almost immediately and tangible financial benefits. So as you can see, there are many benefits of the cloud. The flexibility of cloud makes it easier to develop and deploy applications, or cloud computing enables you to access resources within minutes. So there are lower startup costs for new developments or experiments. And cloud enables organizations to respond at speed to changing needs or demand. And nevertheless, the risk that cloud costs spiral out of control is not to be underestimated, as cloud costs behave differently than the on-premises data center cost. So this also means that if you move towards the cloud but neglect to focus on on optimizing your cloud expenditure, this might result in cloud costs that get out of control. So in the final part, I will be looking into how to manage and optimize cloud spending. And I will use a total cost of ownership calculation of an application migrating to the cloud for that. So when we look at this figure, it shows the total cost of ownership of an application over a 3-year period of time. And it shows basically 3 cost components: the on-premises cost, the one-off costs that are necessary for the migration, and the cloud costs, which can be split in a committed part and a variable part, the pay-as-you-go part. The figure also shows that over a 3-year period, you will be able to make cloud services cheaper than the on-premises cost. But cloud services can also become expensive when procuring with the pay-as-you-go model and prior to intensifying cost optimization possibilities and activities. So basically meaning that in practice, a non-optimized cloud environment can easily be more expensive than an on-premises equivalent. There are also residual or sunk costs of the vacated data center capacity. And common residual costs from a cloud migration include losses in productivity due to the vacated facilities and hardware, unused licenses, and so on. So at the end, in the end, you will only start saving money when you remove your data center overhead, the on-premises one, and optimizing the workloads through cloud financial management. And it could also be that if you look at the migration cost, that migration investments can be too substantial to be paid by the infrastructure cost saving in such a short period of time. Okay, so the first step to manage IT spending is to create transparency. So let's assume that over time there is a sudden increase of costs, and this requires further investigation, as leaving it unaddressed will result in the accruing of costs. So to manage cloud spending, there need to be certain things in place. So first of all, the transparency. So to provide cloud consumers transparency and visibility on what they spend. They should have access to reports that enable them to monitor the cost. And this should result in visibility into who is spending money on which projects and services. There should also be an alerting system because we noticed that cloud spending, the monitoring of cloud spending can be quite overwhelming, especially when cost must be continuously correlated between metrics such as utilization or performance. Therefore, we introduced automation to detect and alert when there's a deviation from a normal trend, so the anomalies. Second is a tagging strategy. And cloud bills, they can be extremely granular, and they can easily reach thousands of line items, even when the consumption is relatively low. So building cost tracking foundations by using tags is really a must. You can use these tags to organize and categorize your resources by application, division, projects, and environment. And the last point I wanted to make is on the chargeback. So, and that also has to do with the behavior of cloud cost. So we are trying to make the cloud consumers accountable for what they spend. So to really provide them visibility on the costs, as well as to incentivize them to pursue optimization opportunities. So with the chargeback model, each division gets an internal bill with the cost of services that they generate. And in the on-premises world, it was always quite difficult to implement showback and chargeback because of the difficulty and complexity. But cloud services basically solve this problem by providing these granular cost metrics programmatically, so making it chargeback somewhat easier to implement. So as mentioned before in the presentation, a non-optimized cloud environment can easily be more expensive than an on-premises equivalent. That's why it's important to continuously focus on cost optimization possibilities. Also because when it comes to cloud, this can result in almost immediate tangible financial benefits. At the European Central Bank, we noticed that we could relatively easily achieve certain cost savings over a 6-month period by implementing a few standard methods of cloud optimization. These examples are scheduling, right sizing, and commitment strategies. And these are things that you can implement without having to re-architecture the entire application. So on the scheduling, I was actually surprised that there were still quite some idle or abandoned instances, which also contribute to waste in cloud spending. So you may have resources that remain only idle in certain hours of the day or certain days of the week. And this is typically behavior of workloads that depend on the presence of developers at work. So scheduling cloud services based on the expected utilization patterns can optimize, can be one of the ways to optimize your cloud expenditure. So basically turning off services on and off and making assumptions on future behavior based on historical data. And this can be quite impactful. You can save up to 70% on development instances if you schedule them to be on for 8 hours a day and 5 days a week. Then there's the resource utilization with continuous right-sizing. So when you provision resources, you must always allocate a number of CPUs or an amount of RAM or the maximum number of IOPS of the underlying infrastructure. And you pay for this allocation irrespectively of whether you are using it or not. And often you end up using resources at a much smaller percentage than what they can deliver. So right-sizing is basically the practice of adjusting a cloud service allocation size to the actual workload demand. And then the last one is on the resource commitment strategies. So programmatic discounts can significantly reduce the cloud bill as well. A programmatic discount can make the actual resource costs up to 70% lower than the pay-as-you-go model. So you basically have to determine your baseline and purchase enough discounts that allow you to cover your stable, predictable workloads. And if you're unsure about how much to commit, you can observe your past utilization and use it to make assumptions about the future. There's also this level of aggressiveness, bearing in mind that more aggressive commitments bear higher risk of spending waste, as shown in the figure. And although programmatic discounts are very effective in reducing your bill, it also bears the risk of causing the wrong consumption behavior. It's easily to fall into the trap of buying larger commitments and then artificially driving utilization up just to match those pre-purchased commitments. And that's exactly the same logic that we used to apply in the on-premises data centers, and that may cause inefficiency as well. So programmatic discounts are a cost reduction practice that can quickly drive your cost down. Together with deleting unused resources and right-sizing, and this practice should basically, was on our list to urgently optimize our cloud expenditure. But on the commitments, you should not rush your commitment decisions because they also bear consequences for medium to long term. Okay, thank you very much for your time. I will now stop sharing the presentation.
Excellent. Thank you very much indeed, Christiaan. Really interesting perspective on the costs in the different environments there. Just a couple of questions, I think, in the chat there. Which tool are you using to get recommendations? Is it out of the box Cloud Console, or are you using any third-party tools or your own tools? Have you done any integration between the CMDB and the cloud spending management environment?
Let me have a...
How do you deal with license management spending and compliance, especially bring your own license?
Okay, let me have a look. So which tools are we using? So we use the tools that are provided by the cloud provider themselves, so AWS and Azure. And because there's a multi-cloud basically, we also use another tool from Cloud Health in order to basically have this information combined together. And about the integration, we do have an integration between the CMDB, which contains all the on-premises infrastructure resources like servers and databases and so on. And this is linked to our financial system, and the same is that we have this integration between the working on that to have this a full integration between tools like Cloud Health and our financial management system as well.
Thank you.
And how we deal with license management, spending, compliance, and especially bring your own license. I'm sorry, I don't think I can answer that question. I'm not involved in that part, I'm afraid.
No problem.
And is our ITSM tool a hybrid view of cloud and on-premises configuration items? So could you maybe otherwise clarify this question? I'm not entirely sure what you mean with that.
Kevin, did you have anything to add to that?
So can you hear me?
Yes, yeah.
Yes.
Yeah, sorry, yeah. I just wanted to know if you've got CIs in the CMDB that you're looking at, which are on-prem, and you've got services that are possibly a combination of a cloud deployment and an on-prem deployment.
Mm-hmm.
Do you have a tool like ServiceNow or Remedy or whatever that can manage and look at both those things simultaneously? Does that make sense?
Yes. Thank you. That clarifies. And thank you for your question. Yeah, so we try to combine these two views in our financial management system. So there's a link between our ITSM tool and our CMDB with our financial management system. And that basically gives the view of a particular IT service on what are the infrastructure resources that this particular IT service is consuming. So that's the on-prem part. In our cloud tooling, so in, for example, AWS, we have a tagging strategy, and it's mandatory to have cloud resources linked to a specific IT service as well. So the IT service are defined in the IT service catalog, and both on-premises infrastructure resources as well as cloud resources, the account is linked to the same service. And this comes together in our financial management system. So basically you could track over time also migrations from on-premises to cloud, or if they have, or if they are using both for a certain period of time, we can basically see what the capacity usage is, as well as the usage of cloud.